So we are on homework from 6.8. We are looking at equations in standard form. So question number 1, what is the form ax plus by equals c called? And just answered it. That is standard form. And that's the equation of a line. So it's the standard form of the equation of a line. So we've used y equals mx plus b, that's slope-intercept. We've used point slope form when you plug in x and y in the slope. And now we have standard form, where the basics of it is you have the x and the y on one side of the equation, and then any remaining whole number with no variable attached to it is on the right side. Okay, so moving on, question 2. So question 2, we're given a situation. Family buys 3 sandwiches, 4 salads, and they spend a total of $36. We don't know the cost of the sandwiches or the cost of the salads, so we're going to let them be x and y. So letter A, write an equation. So we're going to write it in standard form, which again was ax plus by equals c. And so you can see the x and the y are going to be attached to these two numbers. And it's 3 sandwiches with x being the cost of the sandwiches. So that's 3x plus 4 salads. So 4 times the cost of each salad, which is y. And that's, if you added them up, they have to come out to a total of $36. Part B, it says graph the equation. So if we're going to graph this, you can do it 2 ways. You can get this into y equals mx plus b form, or you can get the intercepts, which is what we studied in the notes here. And an intercept on a graph, we start with the graph here. And since this is talking about the cost of sandwiches, we're going to stay in the positives here. If you think about a graph, our y-intercept, we're going to have a y value. We went up, but we're not going to have an x. It's going to be, well, we have an x, but it's 0 because we're not going into the positives or negatives. And same thing with an x-intercept. The y value is 0. The x is something, but the y value is 0. So we can go ahead and find those intercepts by plugging 0 in for either x or y, finding the other one, and that's our intercept point. So we could start out by plugging 0 in for x. This will give us the y-intercept. So what happens is it just falls off. So I have 4y equals 36, and I'm just going to divide by 4 to get the answer to this question. So y equals 9. So my y-intercept is 9. If that was a point on a graph, the x is 0, the y is 9. Oops. And I can do the other way. I can plug 0 in for the y, which will just eliminate it. And then divide by 3, x equals 12, and that's the point where x is 12 and y is 0. So that's my intercept. So if I put those on the graph, if I went all the way over to 12, right here, that's 12, 0, my x-intercept, and my y-intercept is up at 9. Okay, and it would be a straight line from one to the other. Now, the other way we could do this, what I was talking about, is like we know how to do, get this into slope-intercept form. So you would minus 3x from both sides. You're going to have 4y equals negative 3x plus 36. And then you would divide by 4. And so now y equals negative 3/4 x. That's your slope, plus 9. And so I'm going to go ahead and put 9 as my y-intercept, which would be right here, and go down 3 over 4 all the way over, and you would end up hitting this same spot. So that's the other way to do it. But I think it's quicker and cleaner if you just go ahead and find the intercepts, and that's what we were studying in this section. So that's what I prefer you to do, at least in tonight's homework. In the future, though, you can go any direction that you want. Okay, letter C. If the salads, which is y, the cost of the salad is $6.30 each. How much did the sandwich cost? So we are plugging in for our variable. They've given you the value, and you want to find the other one. So they told you the salads, which is y, cost $6.30. And we're going to go ahead and find x, which is your cost of the sandwiches. So we're going to do 4 times $6.30. It's $25.20. We're going to take that off the 36 and see what's left over. And divide it by 3 because we do know that there was 3 sandwiches. And that comes out to $3, 3.6, so $3.60. Part D, give the coordinates of the point on the graph corresponding to your answer in part C. So coordinates are an ordered pair, an x and a y. The answer here for part C, x was 360. I'm going to call that 3.6. And the corresponding y value that matches it is the cost of the salads, which is your y, which is $6.30, which I will list as 6.3. And then part E, give another pair of possible costs for the sandwich and the salad. So you can just basically pick any number that you want for x or any number you want for y, and then you just go solve the other one. You could even get real just kind of creative and say that one of them is free. You could say sandwiches cost $0, and if you put in 0, then we already did this right here, you would get 9. You could put in the 12 and the 0, or you could put in a different number, say $2, and if you did that, you would do 3 times 2, and then you would solve for y. So 6 plus 4y equals 36, minus the 6, so 4y equals 30, divide by 4, and y would equal 7.5. And so then at that point, you plugged in 2 for your x, 7.5. So it would be $2 for a sandwich, $7.50 for your salad. So you can do that to either variable that you please. Go find the other one. All of those points will show up on this line, all possible values, to make it add up to 36 total. So number 3 and 4. All we're doing is giving the values of A, B, and C, so directly pulling it from our standard form equation, just looking at the coefficients and this number over here. So for number 3, A is the coefficient for x, so it's 5. B is the coefficient for y, and since there's a minus there, it's -3. And then C is always the number that's isolated on that side of the equal sign, so C is 9. For number 4, A equals 8. B is the coefficient of y, which we know is a 1. So don't put 0. That would be, I guess, the common mistake there. And C is equal to 2.4. So questions 5 and 6, we're going to find the x and y intercepts like we did earlier, plugging in 0 for one or the other. And then we're going to go ahead and graph the line. So number 5, we have 2x plus 5y equals 20. So first thing I'm going to do, I'm going to plug in 0 for x, which of course eliminates this. So we have 5y equals 20. We're going to divide by 5. So y equals 4. That's your y-intercept, which is at x equals 0, y is 4. And then you would do the same thing. You would plug in now for y, plug 0 in, which eliminates it. And so you have 2x equals 20. You're dividing by 2. And x equals 10. And that's the point. X is 10, y is 0. And we would go ahead and just plot those. So your y is 0, 4. And your x is at 10. Right here. And you would just go ahead and connect that. And if you did a 4-quadrant graph, that's perfectly fine. In fact, that's what was given on the answer key, 4-quadrant graph. So you'll see it would go all the way up into quadrant 2 very far, and of course it would end up down in quadrant 4 as well. All right, and number 6, we have the equation 3x minus 2y equals 12. Let's start with our y-intercept, so plugging in 0 for x, which eliminates that. So we're dividing by -2. Make sure you do divide by the negative. So y equals -6. That's the point 0, -6. And then to find our our x-intercept, we're going to plug in 0 for y. So 3x minus 2 times 0, which gets rid of it, equals 12. So that means 3x equals 12. We're dividing by 3. X equals 4, which is the point where x is 4 and y is 0. And if we go ahead and put that on a graph, we have 0, -6 down here, and 4, 0 right here, and this line will carry through both of those. All right, number 7. Looking at the following situation. So Cheryl scored 27 points total in a basketball game. They all came from 2 or 3-point shots, no free throws. Okay, find 3 different combinations of 2 and 3-point shots that Cheryl may have had last night. I'm going to jump ahead to letter B. Just do letter B first. It says write the equation in standard form to describe the 2-point and 3-point shots. So if we knew how many 2-point shots she made, we would take that number and times it by 2. So 2 times that number. And we would add her 3-point shots and times those by 3. So 3 times however many 3-point shots. Oops. That has to be a different variable because we're talking about different number of shots. And our total has to come to 27. So I think it's easier to actually write the equation first before you try and do letter A, where you find out all these different combinations that you just kind of come up with on your own. But maybe you were able to do it without the equation in front of you, but I think this kind of helps you take a look. I'm plugging a number in for x, and I got to figure out what y is. Now, these need to be whole numbers. You can't have a half of a shot made. So we do need to have whole numbers. And so that means we can't have all 2-point shots, but we could have all 3-point shots. So let's think about that. Different combinations, I'm going to write them as ordered pairs. We could have x equal 0, and if she hit all 3-point shots, that would be 0, 9. Now, if you just take 2 off of this, 3 isn't going to go to 25, so she couldn't have hit 1 2-point shot. So what I think is better is to actually take 3s off of this. And so let's say she hit 1 3-pointer. That would put me at 24 points left over in 2 points, which you could easily get to. So I'm going to say she hit 1 3-pointer. So take 3 off of 27. She scored 24 points on 2-pointers, which means she hit 12 of those. And they wanted 3 different combinations. Yours could have been different than mine. So let's say she hit 2 3-pointers. That would be 6 points. If I take 6 points off, I'm at 21. And she can't get to 21 with all of those 2s. So I'm going to say she took 3 3-pointers, which would be 9. And that would knock this down to 18 points left over. And so to get to 18, counting by 2s, it would have been a 9 and a 3. So all different ones. The book gave 0, 9. It also gave 3 and 7, which would work. And it also gave 6 and 5, which would work. Okay, so there's 5 different ones right there, and there's even more than that. All right, so we already did, that was A. B was with the equation. Letter C, what's the greatest number of 3-points shot she may have made? We can find that right here. Greatest number is 9, because if she made 9 3-pointers, she has hit 27 points right on the dot without any 2-pointers. And then it asks, what's the greatest number of 2-point shots she could have made? So thinking about that, she can't get to 27 just by making 2-point shots. And even if you try to get to 26, you would have then have to hit a free throw and get 1 point to get to 27. But it says that she only made 2-pointers and 3-pointers. So we need to get to 24 since we can't get directly to 27, leaving 1 remaining 3-point shot. So if she got to 24, that would be 12 two-pointers. 12 times 2 is 24, leaving her 1 3-pointer to get to 27. So that's the maximum or the greatest number of 2-point shots that she could have made. All right. And letter E, we're going to go ahead and graph this. Now for this one, you're not going to get a perfect number for your intercepts here. You get the 0, 9. But if you plugged in 0 for y, you're going to end up dividing 27 by 2. So we can go ahead and take a look at that. We already have the y-intercept, so if we graphed this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 9, it's going to be right here. So these are our 3-pointers. So 9. And going this direction, if we were looking for our x value, we would plug in 0 right here, and it would go away. So we'd have 2x equals 27. You would divide by 2, and 27 divided by 2 is going to be 13.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It would be right in between that. Now, obviously, that is not a possibility. But if we drew this line, it would cross right through there. Again, the other way to do this would be to get your intercept and slope from a slope-intercept form. So crossing this out, we would have 3y equals negative 2x plus 27, and we would divide by 3. And so we would have y equals negative 2/3 x, that's your slope, plus 9. So you would start at 9 and go down 2 over 3, down 2 over 3, all the way across. All right, the next question was number 11. They're giving you something in standard form. Here's your x and your y separated from our other number. We're going to find the equivalent equation in slope-intercept form. So slope-intercept is the equation that gives you the slope and the intercept. So we need to get these in y equals mx plus b form. So we're going to isolate the y. So starting out here, got to get y by itself. First thing we need to do is get x on the other side of the equation. So since it's a positive, we're going to do subtraction to move it. We do need to maintain that negative 7y. I'm going to go ahead and put the x up front because that's the form that we're used to, but you don't have to. You could write 308 minus 4x. Since it was a positive 308, I do need to put a plus. Now I'm going to divide by negative 7. And y is isolated. 2 negatives will make a positive. This is my slope. I'm fine with it staying a fraction, so 4/7. And positive divided by negative is a negative, which we write as minus. And now I just need to know what is 308 divided by 7. It's a nice even 44. And that's my answer right there. So this equation is equivalent to this one, meaning if I plugged in, let's say, a number for x and found y here, and it made this equation true, those same x and y's would make this equation true up here. They are equivalent. Okay, and number 12, x plus y equals 0. This one's nice and easy because I don't have a coefficient of y that I'm going to need to divide by. All I need to do is move x to the other side. So y equals negative x plus 0 if you wanted that plus or minus there, but you could just leave this as y equals negative x. You don't need the plus 0, and that's perfectly fine. Also, if you put a 1 in front of it like they did in the answer key, nothing wrong with that, but we know that we don't need to write the coefficient of 1 there. So 14's up next. We're given the standard form of the equation, but all with variables. In letter A, we're going to solve this equation for y, which means isolate the y. It's going to say y equals. So first thing, just like I would do up here, is get rid of this x. So I'm going to minus ax from both sides. That's going to go ahead and leave me by equals, just like I left that x up front because that's the slope-intercept form. I'm going to go ahead and do that. So it's a negative ax up front. That's a positive c. I'm going to write plus c. I want to isolate this y. So again, b represents a number, just like I would divide. Like when I got here and I had negative 7y, I divided. I'm dividing by b. Everything gets divided by b. So this goes away. And now I've got my final answer, negative ax over b. And if you did negative a over b with x sitting next to it, that's perfectly fine. That's what they did in the answer key. But you can put the x up top, plus c over b. Now technically you could put the whole thing, negative ax plus c over b like this, but that is not the perfect y equals mx plus b form that we're looking for, where we clearly see the slope and the simplified intercept. So this is what we're looking for. But again, if you put the x next to it, it would look like this, negative a over b x. That's perfectly fine. Those two say the same thing. Okay, we're going down to number 16. We're in the review section now, so this is no longer dealing with standard form. Looking at some of our other formulas. So find an equation for the line through these 2 points. Anytime we write the equation of a line, we're looking for a slope to plug in. Given 2 points, we're going to have to plug into y minus y1 equals mx minus x1. And we do not have a slope right now. We have an x and a y combination. And so I'll probably use the 6 and the 1 because I don't have to deal with a negative. But before I can do anything, I need to go find the slope here. So it's y2 minus y1, x2 minus x1. And I'm dealing with these 2 points, subtracting my y's, subtracting my x's. It doesn't matter which order you go, just be consistent. So I'm going to go ahead and go from right to left. So subtracting my y's, 1 minus 4. Subtracting my x's, 6 minus negative 3, which will go plus plus. So I'm going to get a negative 3 on top, and I'm going to get a 9 on the bottom. That would simplify to a negative 1/3. So that's my slope. So if I come over here, I'm going to go ahead and plug in negative 1/3 for m. It's going to be x minus one of my points. I'm going to go ahead and use the 6 and the 1. So I'm going to put 6 in, but remember you could use the other one. And then y minus my y value of 1. I need to distribute, and then I'll move this. So I'm going to leave this alone right now. Negative 1/3 x. This is a negative times a negative, which is positive, so I put plus. And taking the third of something is like dividing by 3. And so this is going to be a 2. And I'm going to go ahead and add 1 so that y is now isolated. I have negative 1/3 x plus 3. Now this is slope intercept form, because again, that's what it gives you, the slope and the intercept. You actually could stop here. They didn't say you had to get it all the way to slope intercept. This is the equation of the line. This is point slope form, because that's what it gives you, the slope, and it also gives you a point. And this is the equation of a line. It's not like one is necessarily better than the other. So either one of these answers is correct. This first one, again, could have been given with the same slope, but with the 4 and the negative 3 plugged in the right spot. But if you solved it all the way down and got it to slope intercept form, then obviously that's also really good too. So we're on to number 17. So the water in a 6-foot deep pool is 8 inches deep. So the whole pool is 6 foot deep. It has 8 inches of water in it right now. A hose is being used to fill the pool, and it's at a rate of 4 inches per hour. So there's your rate, which is your slope. Let x be the number of hours passing. So for every number that goes in for x, it's increasing the depth of the pool by 4 inches, or the depth of the water, I should say. And y is going to produce your total inches of water in the pool. So letter A, write the equation. So it's going to be y equals, it's changing by 4 inches every hour, and it's not starting from 0, it's starting from 8. So after 1 hour, you would do 1 times 4. You've increased it by 4, but what was it to start with? It was 8. So our starting equation is y equals 4x plus 8. Now you'll see in the answer key they said y has to be less than or equal to 72, and that is just because this is a 6-foot pool. And so we can't fill it more than 6 feet. It would overflow, and that wouldn't continue to stack on top. So for this, they said y needs to be less than or equal to 72. Where'd the 72 come from? There's 12 feet, 12 inches in a foot, I should say. And so if you have 6 feet, that's 72 inches. And so y can never be greater than 72 inches because the pool is then overflowing, and it's not going to obviously stack up on top of that. Letter B, give the slope of the line. So that's 4. And letter C, use your answer to find out how long it will take to fill the pool. So we've already established that 6 foot deep is 72 inches. So we need to know, when is it going to hit 72 inches? If it started at 8 inches and it's increasing by 4. So to show your work, you would solve this equation. It's full when y equals 72. So 72 minus 8 is 64. And you divide that by 4. And x equals 16. Now 16 what? 16 hours. After 16 hours, this is full. Okay, our next question, staying right here, is 19. What's the probability that you will randomly select a letter that is not the letter U in the word Albuquerque? So first of all, we need our total number of outcomes here. So you would add up all the letters here. 1, 2, 3. There's 11. So it's something out of 11. And our outcomes that we're looking for here are the letters that are not U. So you count up all the letters that are not U. So 1, 2, 3, 4, 5, 6, 7, 8. So you have a 8 out of 11 chance. That's your answer of randomly choosing a letter that is not U. Of course, the other way you could do it is count the U's up. And if there's 3 of them, then you know that 8 are not. Therefore, 8 out of 11 is your answer. All right, and then we also had 20 and 21. It says, tell whether 0, 0 is a solution. So you're basically running a check and seeing, does it work? So plugging in 0, 0, and does it make this inequality true? So if x is 0 and y is 0, does it make this true? This would be 0 minus 0, which is 0. And so you're left with the statement 0 is less than 3. That is true. So yes, the point 0, 0 is a solution to number 20. But 21, I have a feeling, will not be. So 5x is greater than 4 plus 2/3 y. You're plugging in 0, 0. We're testing 0, 0. Is it a solution to this? So 5 times 0, which would be 0. And 4 plus 2/3 times 0, which becomes 4 plus 0. So it's going to say 0 is greater than 4. Is 0 greater than 4? No. So that means the point 0, 0 is not a solution to this sentence or this inequality.